Azure Blob Storage is Microsoft's object storage solution for the cloud. Blob Storage is optimized for storing massive amounts of unstructured data, such as text or binary data. Blob Storage works great for storing files, serving images or documents directly to the browser, creating backups, streaming content, etc. In this video, let's learn how to get started using the Azure Blob Storage, some of the basic concepts, and how to use it from a .NET application to manage files required by the application. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud, and DevOps. Azure Blob Storage is an object storage solution for the cloud. This storage is optimized for massive amounts of unstructured data. Now, this can be text or binary data. Blob Storage is designed for serving images or documents directly to a browser, storing files, streaming video and audio, writing log files, storing data for a backup and restore, etc. Now, when building .NET applications on Azure, if you need to store files or images or asset data that's managed by the application, then Blob Storage is a great solution that would help you. A blob storage offers three types of resources: the storage account, a container, and a blob in the container. Storage account is the high-level namespace or a grouping that is containing all the other containers within that storage account. Within the storage account, you can have multiple containers. These are more like folders to organize the blobs themselves. Now, within each of these containers, we have different blobs. Now, you can see here, there is an account called Sally, which has two containers: pictures and movies. Inside pictures, we have a few JPG images, and inside movies, we have .avi files. Similarly, you could have any number of folders or containers inside here, and each of these containers can have any number of files. Now, another way of visualizing this exact same thing is a large box with container, which is called the account or the storage account, inside which you can have multiple containers of varied sizes, and inside each of them, we will have the actual blob data itself, which is going to be the files. Now, each of these files here can be independently accessed using a URL, which is unique for this particular storage account and the container and the file itself. The storage account provides a unique namespace in Azure for your data. This name needs to be unique across Azure. Now, there are different types of storage accounts that are supported. Based on your requirement, you can pick and choose one of them. We have standard and premium versions for advanced scenarios. Now, a container organizes a set of blobs similar to a directory in a file system. Now, since this is part of a DNS name, the name of a container should match the URI constraint. You can check out these rules in here to make sure that you have a valid container name. Blobs can be of three types. Now, it can be a block blob, which means it stores text and binary data. Append blobs, which are made of blocks like block blobs, but they're optimized for append operation. This is mostly useful when we are storing log information. So it might be blocks of data to which you can append further data. Then we have page blobs, which are basically for storing random access files. This is particularly useful if you're managing virtual hard drive files, etc., which can be served for the Azure virtual machines. So you can store the entire VHD files inside as a page blob. Now, a URI to a blob looks something similar to this. Here we have the storage account name, which is my account, and then we have the .blob.core.windows.net, and then we have the container name and the actual blob's name. So each of the blob inside the Azure storage account within a container has a unique URI. So let's head over to the Azure portal and create a new storage account and start using this. So let's go into storage accounts. Let's navigate to that. And let's create a new one. Here it prompts to select a resource group. So I'll choose a resource group delete. Let's give a storage account name. Now this name needs to be unique. So if I choose a name that already exists, that is going to show an error. So it says the storage account YouTube is already taken. So let's be more specific. So let's say YouTube demo app, and we can see this storage account name is available. So let's scroll down. Let's choose the type. So in this case, I'll choose standard. You can also choose the redundancy options. So I'll leave this as default. Now, based on your application's requirement, you can choose the different redundancy options that's supported in here. So we can either click next step and select the advanced, or directly review with the defaults and create it. In the advanced section, you have the different options that's available to configure for this storage account. You can enable the access tier, which is hot or cool. Cool is usually required when you're using this for backup scenarios. You can also go through this other advanced options in here. So let's directly click review and let's click create. This is going to create a new storage account inside my Azure account. Let's go to the resource, and here you can see the storage account being created. You can find all the different details in here. In a previous video, I did cover about the Azure Queue service, which is also part of this storage account. That video will be linked here and in the descriptions below. Now, if I navigate on the left, you can see containers option, which is where we are going to create the storage containers. In here, there is a default $logs folder, which is created because we enabled analytics on this storage account. So let's create a new container inside this, and let's name this as images. So this creates a new container within our storage account. This is very similar to being a folder. So let's navigate into that, and we can start uploading actual blobs or files in here. So let's click upload, and let's drag and drop a file into here. Now, since this is images, I'm going to drag and drop an image in here. But this is not restricted by the name. You can upload any kind of files inside this container. It's more because of a naming convention that I'm uploading just images under this. So you can also override the files if it already exists, and look at the other advanced options. In here you can see it supports the block blob, and you can also choose between the different blobs that we saw earlier. So let's leave it with the defaults and click upload. Now this has successfully uploaded that file. So if I navigate into that file, you can see the further details of that specific file. So in this case, you can find the URL to this file in here. So if I copy this, and let's navigate to that file in the browser, which is going to be with that format, our storage account name .blob.core.windows.net, the container name, and the actual file name. So let's navigate to this, and this says the public access is not permitted for this storage account. By default, all the documents or blobs that we create or update is protected and private, which means we need to authenticate to get access to this file. Now, to change the access level of this, we'll need to enable this for the container level itself. So to do that, let's come back to our storage account. Let's scroll down to configuration, and let's select allow blob anonymous access. So let's say enable for this, and let's click save. Now, once we enable anonymous access at the storage account level, navigate to one of the containers, and let's go to the file that we just uploaded. And let's click change access level and select this to be blob anonymous read access for blobs only. Now this is going to give access for this file. So if I navigate again to this URL and refresh this, you can see we can access this file now. So that file is now public. So anyone with this URL can access this file. So let's come back in here. Let's go to our images folder. So let's go back into our containers, and let's create a new container. So let's call this as app files. Now you can also set the anonymous access level at the container level. So if I set this to be blob anonymous, any files inside this is going to be public. But let's leave it as private for now, and let's click create. Now here we have another folder which is app-files. So let's upload another file in here. So let's click upload, and let's drag and drop another file, and let's click upload. Now here I have a weather.json file that's uploaded inside here. Now like before, you can select this and change access levels from here. So you can select this blob alone is going to be anonymously accessed. So which means if I navigate into this and copy this, you can get access to this file. You can also get access by generating a shared access signature, which is going to be a unique URI that has the authentication details within that. So if you see, you can see different signing methods in here, and it creates a different token URL. So let's click the generate token URL, and this is going to create a URL which has all the details inside here on how to authenticate with this blob storage. So if I copy that and navigate to this, that's also going to give access to that file directly. So this is going to work even if this object was going to be private object. So if I navigate back and change this as private and navigate back to this URL, I still can access it. So if I navigate to the URL without any access information, this is going to say that the specified resource does not exist. So let's come back. Let's turn this back on for public so that we can start using this when we build our application. So let's switch over to Visual Studio and see how we can start accessing blob storage from code. So here I have an existing solution open, which is a default ASP.NET Core Web API in .NET 8 with minimal API support. So if I navigate to the program.cs, you can see this is the default file which has an endpoint for map get weather forecast. This is simply getting a list of data from here and returning that in this get call. So let's replace this to get this data from the blob storage. Now to start working with Azure Blob Storage from .NET, we need to add a NuGet package. So let's right click on the project and say manage NuGet packages, and let's add a new NuGet package. So let's search for Azure Blob and let's add the Azure.Storage.Blobs NuGet package. So let's select the stable one. So let's select 12.9.1 and install this. The Blob Storage NuGet package has the following .NET classes to interact with the resources. So you can see that it supports a Blob service client, which is required to manipulate and interact with the containers. Now the Blob container client allows you to manipulate data within that containers, and the Blob client is required to manipulate individual storage blobs. So you can see that the Blob service client is mainly at the account storage level, the container client is mostly at this level, and the blob client is for the blobs itself. Each of these clients is in a hierarchy and you can use based on what kind of action that you're looking for. We'll see how each of these ties together later in this video. So let's navigate back to our solution and let's replace this get to get the file from that blob storage. Now in this case, since we are going to directly read a file from the blob storage, which is going to be this weather.json, so let's copy this URL again. Let's read this JSON file and return that inside here. Now since we are directly working with a blob, we can create a blob client. So let's create a new blob client. So let's call this as blob client. Let's create a new instance of blob client. So this is coming from the Azure.Storage.Blobs namespace. So let's make sure to include the appropriate namespace. Now in this case, we need to specify the URI of the blob that we're going to access. So let's create a new URI in here and pass in the string that we copied. So this is going to be the full URL to that exact blob file. Now in this case, since this is currently a publicly available file, I don't need to specify any storage keys to access this. So let's simply create the client, download the contents. So let's call this as weather file to the blob client. So let's use the download content async method in here to download the file. Now since this is an asynchronous file, let's make sure to add the await, and let's also make sure to make the function as async. So this is going to make this function async and download this content async. Now once we have the file, we can convert this into JSON format. So let's use the JSON serializer.deserialize and let's specify the weather forecast as the type. Since this is going to have a list of weather forecasts, let's give this as a list of weather forecast data, and let's use the contents that we have downloaded. So let's specify the weather file dot value to get the actual file, and let's get the content and then convert this as a string format. Now once that is converted, it is going to return this back as a JSON data. So let's put a breakpoint here and run this to see this in action. So this launches the Swagger UI, which is defaultly configured for an ASP.NET API. So let's navigate in here, try it out and click execute. Now this first creates the blob client and it downloads the weather file. And you can see here this content has this JSON representation, and continue the execution. And you can see the response body having the data from the file that we uploaded. So it has all the hard-coded data inside that file being returned inside this. So this is now reading the file data from the blob storage and returning this to this API. Now let's see, once we make this file as private, how we can access this. So let's navigate back to our storage and let's modify this blob access to be private. So let's select that and click OK. Now this file is now private, which means the API will not work anymore. So if I try to access this content again, this is going to throw an error because it does not have access to this file in specific. So you can see here server failed to authenticate the request. So let's see how we can update our code to add some authentication. So if I navigate back into the storage container, you can scroll down and see the access keys section. Now this gives you the connection string that's required to connect to this storage account. So there are two connection strings that's provided, key 1 and key 2. This is basically for support of rotation. So you can start using key 1 initially, and once you need to rotate the keys, you can replace your applications to use key 2, and once all the applications are on the new key, you can rotate this key 1. And similarly, you can keep going between the key 1 and key 2. Now, once you copy this key from here, you can use this from within the application. So inside here, let's say new blob client, and you can pass the storage credentials inside this. So here you can create a new storage shared key credential and pass in the account name and the key that you just copied. Now, you would ideally be managing this inside your app settings file and getting it from there. Now, if you want to learn different ways of managing sensitive and secret information inside applications built on Azure, check out my video linked here and also in the descriptions below. Now, rather than having to store these credentials and managing them explicitly, it would be nice to not have that in the first place. Now, Azure Managed Identity is a way that you can achieve this. So if you're new to Managed Identity, check out my video that will be linked here. In short, instead of using the storage shared key credential, we can use a new object which is going to be default Azure credential. Now this is going to come from a different NuGet package. So let's check for this type on NuGet.org, and let's add the Azure.identity NuGet package. So let's make sure to install this inside our application. So let's click install, which is going to install the Azure Identity NuGet package. So once that's complete, we can import the missing references in here and start using this. Now the default Azure credential, so if I navigate into that class, uses different credential options to authenticate with this resource. So initially it will look at the environment credential, then the workload identity credential, managed identity credential, shared token cache credential if one is specified at the environment level, Visual Studio, and lots of other options. So it will go through each of these in this order and see if any of this is configured. Now, once your application is deployed onto Azure, you can enable it on the Azure resource that it's deployed on. So if you're working on an Azure function or a web app, you can enable it on that particular resource. Check out my video on default Azure credentials to see how that works. Now, in my case, when you're running from a local machine, I have set it up on my local machine as well. So if I navigate to Tools, Options, and let's navigate to the Azure Service Authentication, and in here you can see the account that it is using to authenticate against this. So I'm using this particular user account, which will be used as the Visual Studio credentials that we just saw. Now this is an account that I explicitly added to Visual Studio using this button on this top right. So let's go and make sure that our Blob Storage account has access to that particular email account. So if I navigate into the Access Control IAM, let's click on Add, and let's say add role assignment. So in this case, since I'm only interested to give assignment for the blob, let's give a storage blob data contributor role, and let's click next. Let's add the members. So in this case, I know which member to add, which is the same member that I have given access in the Visual Studio. So let's select that and let's click select. Now, once we have that, let's click review and assign, and now give this access. So now this is adding the role assignment, which is now complete. So if I navigate to role assignments, you can see this role assignment in here, which is given the storage blob data contributor. Now this is the same email that I had used in my Visual Studio account. If you want to see how to set up your local dev environment with default Azure credentials, check out the video that's linked here. So let's navigate back to Visual Studio. So let's put a breakpoint again and let's run this. Let's select try it out and let's click execute. Now this is going to hit create the blob client using the default credential, and it's going to download that file. Now initially it's going to take a while to retrieve the token that's required and navigate through the different levels that it is configured for. Now once that's successful, because I have the appropriate permissions added for this account that it's using, the file is getting downloaded successfully. Now it returns the JSON file and it returns that data inside here as expected. Now let's see how we can add a new file from within our application. So let's close this. Let's create a new endpoint in here. Now, since this is going to be a post, let's create a app.map post endpoint. Let's give this the name under the same weather forecast. So let's keep the name the same for this, and this will be a post endpoint in here. Now, this is again going to be asynchronous since we are going to post content in here, and that's going to be from the form since we are going to be having a data uploader. So let's specify from form attribute, and let's use that. Now, in this case, we can create a new class. So let's create a new class called file upload request, and let's simply call this as data. So we can create this new class as a record inside here. So let's create a record file upload request. Let's pass two parameters in here. One is going to be a iForm file, which is going to be the file itself. And let's also give the container name that it needs to upload to. So let's specify a container name. So this is simply going to create a file upload request, and let's use this data. Now in this case, let's see the different object models that's supported. So instead of using a blob client directly, let's start using a blob service client. So that was the initial level for the account storage level. So let's use that and see how we can build down to reach the actual blob client. So let's create a new instance of the blob service client. So let's create blob service client, and let's create a new instance of blob service client in here. We need to specify the URI of the storage account, which we already have. And we also need to pass the authentication mechanism. So in this case, let's again use the default Azure credential for our scenario. So let's specify that. Let's copy this storage account URL. So let's just copy the initial part and pass this as the URI in here. So we have the URI and the credentials specified, and we create a blob service client. Now from this service client, we can create a container client. So let's create a container client in here, and let's use the blob service client and specify the create blob container if it's going to be a new container. Now, if it's going to be an existing container, you can simply say get blob container client and pass in the blob name. So let's specify the data.container name inside this. So all this get blob container client is doing. So if I navigate into that using F12, now since I have resharper configured, it's going to show me the implementation of this function. So here you can see that all this is doing is creating a new instance of the blob container client, and it's specifying the container name and passing in the configurations to it. So all this function is doing is creating a new instance underlying. This is very equivalent even if we created a new container client directly using this container name. Now once we have the container client, we can use this to upload the file. So let's retrieve the file stream. So let's open a using statement on the stream, and let's get this from the form file. So let's say data.file open read stream. Now this is going to open the stream to that particular file that we have uploaded. Once we have that, we can use the container client dot upload blob async, pass in the file name data.file name, which is going to be the file name, and the stream that we just opened. So we're using the upload blob async in this case to upload this file. Let's complete our map post endpoint. So let's specify with name post weather forecast. Let's disable anti-forgery in this case because I don't have any authentication set up. And let's also say with open API. So this is going to set up our post endpoint in here. Now once this is done, let's run this and see this in action. So this opens the Swagger. Let's go to the post and let's try it out. So here we have a choose the file. So let's select a new file, which is weathernew.json, and let's specify the app files container itself. So this is going to already exist. So once we click execute, it's going to create a blob service client. From that, it's going to create a container client instance. And now it's going to open the stream to the file and actually upload this file to this blob storage. So if I press F5, that's going to upload this file into our blob container. So if I switch over to the Azure portal, navigate to the containers and to the app files, we can see that the new file is successfully uploaded. So you can see this is going to be weathernew.json. Now if I come back and try to upload this file again, so let's choose another file and say the exact same file weathernew.json, and let's try to execute this. Now in this case, it returns back with an error which says the specified blob already exists. Now this is because overwriting the file is by default disabled. So let's navigate back to our source code and see how we can solve that. Now, if you go to the upload blob async method on the container client, you can see that all this is doing is getting a blob client internally and calling the upload async on that. Since it knows that this is working on a blob, it's automatically going down one level on the client, getting the blob client and using the upload method. Now in this case, it's going to call the upload with the default parameters, which means the overwrite is false. So we'll have to directly use the upload async on the blob client if we need to overwrite this file. So let's navigate back to the program.cs. And now once we have the container client, so if we need to overwrite, instead of using the function on the container client, we'll need to use it on the blob client. So let's create the blob client in here. So let's specify blob client, use the container client and specify get blob client. Now in this case, we can pass the name. So let's specify the data.file name in this case. Now in here, it's just creating a pointer to that. Even if this file does not exist, that is okay. Now we can start using this blob client. So let's specify await blob client dot upload async. Let's specify the content. So in this case, let's specify the stream and let's also specify the overwrite to be true. Now, since the name of the file is already specified in here, we don't have to repeat that again. So now in this case, so let's run this again. Let's come back to the files. Let's make sure to delete this and try uploading this again. So now I have removed that new file from here. So let's navigate back to our Swagger and let's try it out and upload this file that we tried earlier. Just whether new, and let's specify the container name as app files and let's click execute. Now the first time there is no file existing with that name, but it's going to upload that as a new file. This request is successful. So if I navigate back to the container and refresh this, you can see that file is there. Now let's see if we can update this weather.json file and retrieve this back in our API. So I have the weather.json file open here. So let's say sweltering updated so that we know that this is an updated file. And let's upload this again using the API, which is going to be the weather.json. So let's choose that file. Let's choose weather.json and execute this. Now in this case, this is going to overwrite the file because it already exists. Since we explicitly use the blob client and specify the overwrite to be true, this time it is successful. So now if I navigate back to the get and try it out in here, this is going to return this updated file. As expected, you can see the response and it is sweltering updated. So we successfully uploaded a file and retrieved that in our get call. Now similarly, we can also add a delete endpoint to manage the file. So let's go and add that last endpoint in here. So let's specify app.mapDelete. Let's specify this as /weather forecast. Now again, all we need is the container and the file name. So in this case, I'll just get the complete name as one parameter. And let's create a new function. Now, since we have the full file name, we can directly create a blob client if required. So let's create a new blob client, Let's pass in the new URI. So we have the URI in here. So let's copy and paste that. We can use string interpolation, or you can actually build up using the different ways that's supported earlier. In this case, for ease of use, I'll simply use string interpolation and specify the full file name, assuming this is going to be in the correct format. If not, you can use the blob service client, create the container, and then try to get the file and then delete it. Now we also need to pass the authentication option. So let's use default Azure credential. Now once we have the direct blob client, let's call the delete if exist async. So this is going to delete only if the file exists. And let's click await in here. And let's specify with name. This is going to be delete weather forecast. And let's also say it with open API. Let's run this and see this in action. So let's delete the weather new.json. So let's copy that full path. Let's navigate back to the Swagger. Let's go to delete, try it out, and let's paste it in here. So all we need is the last part of the file. So let's just paste in that app files and the actual file name, and let's click execute. So this is going to create the blob client and delete if this file exists. Now this is returned back with a 200. So if I navigate back to here, and let's refresh this container, and you can see that file is successfully deleted. So based on your application scenarios, you will be picking and choosing one of these clients between the Blob Service Client or the Blob Container Client or the Blob Client. Now, using the Blob Service Client, you can create new Blob containers within that account. Now, in all these cases, we used default Azure credential, which removes any need of managing sensitive keys by your own. I hope this helps you to get started with Azure Blob Storage and start using it from a .NET application. We learned the different concepts of the blob storage, how they are organized, and we also learned how to connect to it from a .NET application. We learned how to use the default Azure credentials so that we can bypass the need for storing and managing secret information. In a future video, I will show you how to introduce dependency injection into this code so that you can manage these client instances using the dependency injection container. If you want to be notified of that video, make sure to hit the subscribe button. If you also like this video, please make sure to hit the like button. It helps me to grow this YouTube channel. Thank you and see you soon in the next video.